Health researchers today are sitting on just mountains of data. Information that could literally hold the keys to curing diseases. But there's this one huge challenge they face every single day, something that stops them from connecting all the dots. So how in the world can they take information from, say, a study in Boston, another one in Berlin, and a third over in Tokyo and get it all to work together? Really make sense of it all? That's the billion-dollar question, right? And it's exactly what we're going to unpack today. Okay, so the core of the problem is, well, it's this. Every single research study is kind of like its own little island. They all collect data differently, they measure things in their own way, and they store it in totally different formats. You just can't mash it all together and hope it makes sense. It just doesn't work like that. All right, to make this really simple, let's use an analogy that I think you'll get right away. Imagine you have three amazing chocolate cake recipes from three of the best chefs in the world, and you want to combine them to create the ultimate chocolate cake. Sounds good, right? But one recipe measures flour in grams, another uses cups. One tells you to bake at 350 Fahrenheit in a gas oven, while the other says 180 Celsius in a convection oven. You can't just mix and match those instructions. You'd end up with a total disaster. And believe it or not, that's the exact problem scientists are facing with health data. So for years, the way people tried to solve this was what they call ad hoc, which honestly is just a fancy way of saying they kind of made it up as they went along. And this process, it was incredibly slow and, frankly, super painful. It often led to really poor quality data that you couldn't rely on, and it created these massive delays that slowed down the pace of real scientific discovery. So what's the solution then? Well, there is one. It's a process called data harmonization. Now, the official definition might sound a little technical, but the core idea is actually really simple. It's all about creating a standard, right? A common language, so that all these different data sets can finally talk to each other. Think of it like creating a master recipe book for all those different cake recipes. And hey, this isn't just some vague idea. There's a real structured plan for it. It's called the Conceptual Framework for Health Data Harmonization. I know this diagram might look a little complex at first glance, but just think of it as the official blueprint. It's the step-by-step guide for turning that whole mess of different data points into one clean, super powerful data set. The process itself is actually very logical. First, you gather up all your different recipes, your data sets. Then you pick out the ones that are the best fit to be combined. Step 3 is where the real magic happens, the harmonization. That's when you translate everything into that common language. Then, and this is crucial, you check your work to make sure the quality is top-notch. And finally, you create that single, clean data set that's ready for scientists to get to work on.
But wait a second, here's the key question, isn't it? How do you actually decide if two recipes or two data sets are even similar enough to try to combine? You can't just combine a recipe for chocolate cake with one for beef stew, right? That's not going to work. Well, the framework has a really clever system for figuring this out.
This table here shows you exactly how it works. The framework compares everything on 4 key levels. First up, study design. Basically, are we even studying the same thing? In our analogy, it's asking, are we both making a chocolate cake? Makes sense. Second, structural similarity. Is the data organized in a similar way? Do our recipes have roughly the same number of steps? Third is metadata similarity. This is basically the data about the data. Are our ingredients fundamentally the same? Flour, sugar, eggs. And finally, data significance. This is where we get into the actual numbers. Are we using the same amount of flour and sugar? By checking these 4 things, the framework can say with confidence, yep, these can be combined, or nope, these are too different. And let me tell you, the difference this makes is just enormous. The old ad hoc way, it was a slow, error-prone mess. This new approach, using the framework, is systematic and repeatable. It doesn't just combine the data, it actually improves its quality and makes it way more useful for analysis. And it does it all so much more efficiently. And all of that work, all of that structure, it all leads to this one beautiful outcome, a single unified data set, one source of truth that is reliable, powerful, and ready to help researchers make some serious breakthroughs. So really, the crucial point here is this. Data harmonization isn't just about, cleaning up a bunch of spreadsheets. It's about having a systematic, intelligent framework that transforms a chaotic jumble of information into an incredibly precise and powerful tool for science. It's what turns a pile of random, mismatched recipes into a Michelin star meal.
And that really leaves us with a final and pretty massive question. If we can actually get all of our global health data to speak the same language using frameworks just like this one, what currently unsolvable mysteries do you think we might finally have the power to solve?